Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through my last video on time and work where I have explained the unitary and the LCM method, and I have also explained how we can approach time and work problems with same and different efficiencies. If you haven't gone through that video till now, I have given the link in the description box. You can go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to do some word problems on time and work. So let us start with today's video. Let us start with this question today. A and B can complete a job in 24 days working together. A alone can complete it in 32 days. Both of them work together for 8 days and then A left. How long will B take to complete the remaining work? Well, this question can be solved by using the unitary method and also by using the LCM method. But it is always better to go with the LCM method as the calculation will be very easy in that case. So if we simply use the LCM method, in that case, the LCM of 24 and 32 would be simply 96. So we can say that A and B together can complete this 96 unit of work in 24 days. So we can say that A plus B in one day can do 96 upon 24, that is 4 unit of work. In a similar way, A alone can complete this 96 unit of work in 32 days. So A working alone in one day would be able to complete 96 upon 32, that is 3 unit of work. So we can say that B working alone in one day would be able to do 4 minus 3, that is 1 unit of work. Now it has been given that both of them work together for 8 days. Now I know that A and B together can do 4 unit of work in one day. So in 8 days, A and B would be able to do 8 into 4, that is 32 unit of work. So the remaining work would be simply 96 minus 32, so that is 64. So this unit of work is still remain and would be completed by B working alone, and we know that B can do 1 unit of work in one day. So this 64 unit of work can be done by B in simply 64 days. So that's the answer. Okay, so let us see this question now. To do a certain work, A alone takes thrice as long as B and C. B alone would take twice as long as C and A together. All three can complete the work in 3 days. How long would each take separately? So here it has been given that A alone takes thrice as long as B and C. So we can say that the efficiency ratio of B and C and of A would be simply 3 and 1, and the efficiency ratio of C and A to that of B would be simply 2 by 1. And together they can complete the work in 3 days. So whatever the total work we assume, it should be a multiple of 3. Also here the efficiency would be total 4, and here the total efficiency would be 3. So we can say that one day's work should also be a multiple of 4 and 3, that is 12. So let us assume that the total work should be 36 units. So I can say that in this 3 days, A, B, and C can complete this 36 unit of work. So in one day, A, B, and C would be able to complete 36 by 3, that is 12 unit of work. Now it has been given that the efficiency ratio of BC and A is 3:1, and the total work that they can do in one day is 12 units. So we can say that in one day, A would be able to do simply 1 upon 1 plus 3, that is 4 times of 12, that is 3 unit of work. In a similar way, the efficiency ratio of CA and B is given to be 2:1. So we can say that in one day, B would be able to complete 1 upon 1 plus 2, that is 3, times of total, that is 12, which would be 4 unit of work. So in one day, A would be able to do 3 unit of work, B would be able to do 4 unit of work. So C would be able to do simply 12 minus 4 plus 3, that is 12 minus 7, that is 5 unit of work. Now we have the total unit of work and we have the total unit of work of A, B and C per day. So we can find the total number of days that each A, B and C would be taking to complete this work. So for A, the number of days required to complete the work would be simply 36 by 3, that is 12 days. In a similar way, for B, it would be 36 by 4, that is 9 days. And for C, this would be 36 by 5, that is 7.2 days. So we can see how by simply assuming the total work to be some units, we can solve this question in a very efficient way. Okay, so now let us see this pipe and cistern problem. Pipe P can fill a tank in 16 minutes. Pipe Q can empty it in 24 minutes. If both the pipes are opened, after how many minutes should pipe Q be closed so that the tank is filled in 30 minutes? So after some time, pipe Q is being closed, but for this complete 30 minutes, pipe P has been opened. So we can again assume the total capacity of the tank to be some unit, which we can get simply by taking the LCM of 16 and 24. So LCM of 16 and 24 would be simply 48. So let us assume that the total capacity of the tank is 48 units. So pipe P is filling this 48 units in 16 minutes. So we can say that every minute or in 1 minute, pipe P would be able to fill 48 by 16, that is 3 units of the tank. In a similar way, every minute, pipe Q would be able to empty 48 by 24, that is 2 units of the tank. So we can say that if both the pipes are opened, then every minute they would be able to fill 3 minus 2, that is 1 unit of the tank. Now it has been given that pipe P is being opened for the complete 30 minutes. So in 30 minutes, pipe P would be able to fill 30 into 3, that is 90 unit of the tank. But the capacity of the tank is 48 units. So we can say that 90 minus 48, that is 42 units has been drained by pipe Q. And we know that every minute Q is draining 2 units of the tank. So 42 units would be drained in 42 by 2, that is in 21 minutes. So we can say that after 21 minutes, pipe Q has to be closed so that this tank can be filled in exactly 30 minutes. Okay, so now let us see this question. 20 men complete 1/3 of a piece of work in 20 days. How many more men should be employed to finish the rest of the work in 25 days more? So that means these 20 men are completing 1/3 of the work working for 20 days. We need to have some more men such that the rest of the work, that is the remaining 2/3 of the work, can be completed in 25 days. If we simply apply the concept that we have learned in the last video, we can say that the number of men initially was 20. Work that has to be completed is 1/3, and the number of days required is simply 20. Now, some more men has been employed. Let us assume that the total number of men is now, say, X. So this X men would be completing the remaining work, that is 2/3 of the work, in another 25 days. So we can simply write X would be equal to 20 times of. Now the work done that has to be completed initially was 1/3 of the work. Now we need to complete 2/3 of the work. So we can say that the work has doubled. So we need to multiply with a ratio which is more than 1. So this would be 2 by 3 upon 1 by 3. Now for the number of days, initially the number of days was 20. Now the number of days is 25. So since we have more number of days, so the number of men required would be lesser. So in this case, we need to multiply with a ratio which would be less than 1. So this would be 20 upon 25. So now if you simplify, this would be 20 times of 2 into 20 upon 25. So if you calculate this, this would be 32. But we need to find how many more men should be employed. So initially there were 20 men. Now the total men are 32. So the new men employed is simply 32 minus 20, which is 12. Okay, so let us see this question now. 2 men and 3 women working together can finish a piece of work in 10 days, while 4 men working together can do it in 10 days. In how many days will 3 men and 3 women working together finish this job? So in such kind of question, it's always better to find the efficiency ratio of men and women. So here it has been given that 2 men and 3 women can finish this work in 10 days and 4 men together can finish this work in also 10 days. So let us assume that the efficiency of 1 man is M and the efficiency of 1 woman is W. So 2 men efficiency would be 2M and 3 women efficiency would be 3W. Also we have 4 men, so 4 men efficiency would be 4M. Now 2 men and 3 women, that is 2M plus 3W, can complete the work in 10 days and 4 men also complete the work in 10 days. So we can say that 2M plus 3W would be equal to 4M. So from here we can say that twice the efficiency of men would be equal to thrice the efficiency of women. Now we need to find if 3 men and 3 women works together, in how many days they can finish this job. So 3 men and 3 women efficiency would be simply 3M plus 3W. And we know that twice of the efficiency of men is thrice of the efficiency of women. So this thrice of W can be written as 2M. So this would be simply equal to 5 men. So simply we need to find if the efficiency of the work done is 5M, in how many days can the work be completed. It has been given that 4 men can complete the work in 10 days. So we can say that 4 times the efficiency of men takes 10 days to complete the work. So we can say that 1 times the efficiency of men would be taking 4 into 10, that is 40 days to complete the work. In a similar way, 5 times the efficiency of men would be taking 40 by 5, that is 8 days to complete this piece of work. So in such kind of problems, simply we need to find the ratio of the efficiency of men and women, and we can solve the question very easily. Let us see this question now. 2 taps fill a tank in 40 hours and 60 hours respectively. If they are opened turn by turn each for an hour, starting with the first tap, then after how much hours will the tank be full? So there are 2 taps, T1 and T2. So tap T1 is filling the tank completely in 40 hours and tap 2 is filling the tank completely in 60 hours. So for the first hour, tap T1 is open, and then for the second hour, tap T2 is open. For the third hour, again, tap T1 is open. For the fourth hour, tap T2 is open, and so on. So after how much hours will the tank be full? So again, let us assume the total capacity of the tank to be the LCM of 40 and 60. So the LCM of 40 and 60 would be 120. So let us assume that the capacity of the tank to be 120 units. So every 1 hour, tap T1 would be able to fill 120 by 40, that is 3 units of the tank. And every 1 hour, tap T2 would be able to fill 120 by 60, that is 2 units of the tank. So we can say that for every 1 plus 1, that is for every 2 hours, the tank would be filled by 3 plus 2, that is 5 units. So now Let us calculate how many this 2 hours period will be getting to fill this 120 units. So this would be simply 120 by 5, that is 24. So that means there has to be 24 2 hours period to fill this 120 unit of the tank. So the total time would be simply 24 into 2 hours, that is 48 hours. So that's it for today's video, in which we have seen some word problems based on time and work topic. But I would request you to practice more questions on this topic, because the more you practice, the more you learn. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.